Hi guys, Dr. Justin Souther here. We're going through semester test 1 and we're doing question number 7. Solve the inequality and express your answer in interval notation. Some of you gave me all the notations in the hope that you would get the interval notation as one of them. Right, 2x is less than 10. There's nothing tricky about this. There's no absolute value sign, so you don't need to split this out into 2 is greater than 10. I don't know where negative 10 some of you came up with. This is simply x is less than 10 divided by 2. Now it's divided by a positive number, so we don't have to change this or anything. We don't have to split into 2 because there's 2. It's just divided by 2. So x is less than 5. That's half a mark right there. Now we need to express it in interval notation. What's that one? Well, that's where it's an interval. X is an element of the interval from minus infinity up to 5. We use round brackets always for an infinity, and we use a round bracket for the 5 because it's not included. We use a square bracket only when it's less than or equal to. And there's your other half a mark right there. Okay. Now we want to again solve this and express our answer in interval notation. X cubed is greater than or equal to 3x minus 2x squared. Let's rewrite this as x cubed plus 2x squared minus 3x. Notice that I'm writing it in descending order of powers of x because that's how we're used to seeing polynomials, and that's greater than or equal to 0. Now most of you noticed that all of the terms have an x in them. Some of you tried to factor out a term using long division. That's of course not necessary because they've all got an x. We can factor out the x first. X squared plus, when you factor out the x, you're left with 2x, and here you're just left with 3. For all of you who divided away the x and just cancelled it, shame on you. You can't do that. Why? Because what if x is equal to 0? If x is equal to 0, you certainly can't divide by 0. You've got to keep that term, that factor, and you'll see now why that becomes important. Okay, so you've got x into x squared plus 2x minus 3. Now we can factorize this quite easily. It's going to be 2 factors. We're going to have an x and an x, and we've got a minus 3, so it's probably going to be a 3 and a 1. And yes, we want a 2, so it's going to be a plus 3 to give us this the bigger value there. Minus 1, when you multiply 3 and minus 1, you get minus 3, and when you add them, you get 2, which is exactly what you want. And now we've got a fully factorized expression here. Now, again, you can't divide this x away. This x is a critical value. So some of you divided the x away and just ended up with 2 critical values. There are 3 critical values here. There are 3 times where this expression, this function, will cross the x-axis. And what are they? Well, it's 0 when x is equal to 0. It's minus 3 because minus 3 plus 3 is 0. And of course, it's 1 over here. Now, another thing that a lot of you did at this point was to simply say that, well, if this is greater than or equal to 0, then one of these must be greater than or equal to 0. That's absolute nonsense. Okay, what does this actually mean? This means that when you multiply these 3 things together, you get a value that is greater than or equal to 0. If one of them is 0, you get a value that is 0. But we want to know when you multiply them together and you get a value bigger than 0. Now, you've got to look at when they're positive and when they're negative. If all of them are positive, you'll get a positive value. If one of them is positive and the other 2 are negative, negative terms and negative terms are positive, you'll get a positive value. But if 2 of them are positive, one of them will be negative, it'll be negative. And if all 3 of them are negative, you'll get a negative times a negative times a negative. That'll give you a negative. Okay, so that's why we do this table method, because we need to know what happens depending on whether they are positive and when they are negative. And the critical values are the values when each of them changes. So this one changes from positive to negative at 0. Less than 0, it's negative. Greater than 0, it's positive. This one changes at minus 3. Less than minus 3, this factor is negative. Greater than minus 3, because we're adding 3 to the x, this factor is positive. Less than 1, this factor is negative. Greater than 1, this factor is positive. So that's the whole point. So we need to set up a little table over here Now we've got 3 critical values. So we start with this order is also so important. We start when x is less than minus 3. Then we have from minus 3 up to the next biggest value, not 1. It's very important that we do the order correctly. Then we have from 0 up to 1, and finally we have greater than 1. We've got 3 factors that we need to check. Again, quite a few of you left out x as a factor. And finally, once we've got all of the positive and negatives of the 3 factors, we can work out the positive or negative of the whole expression. Right. So, x, as we said, x is going to be negative when it's negative, so when it's less than 0, and it's going to be positive as soon as we get above 0. X plus 3. Right, less than 3, it's going to be negative. This 3 is not going to be big enough to cope with this x being less than negative 3. But as soon as x is greater than negative 3, this plus 3 is going to take it above 0. Okay? When it's a half, when it's greater than 1, certainly it's going to be positive. X plus 1. Right. When x is less than negative 3, of course this is going to be negative because the 1's not going to be nearly great enough. Pick a value between minus 3 and 0. That's... Oops. This x plus 1 here is supposed to be an x minus 1. My apologies. Okay, let's just go through that again. So when x is less than minus 3, x minus 1 is certainly going to be negative. When x is between minus 3 and 0, well, we're starting with a negative number and we're subtracting 1, so it's still going to be negative. And when x is less than 1, greater than 0, pick a value half. Half minus 1 is negative. It's going to be negative. Okay, it's got to be bigger than 1 before subtracting 1 is going to make the outcome positive. Now we've got all our values here. We can work out the sign of our whole expression, which is what we're interested in. We want to know when this whole expression is greater than 0. Well, 3 negatives multiplied together give you a negative. 2 negatives and a positive will give you a positive. 1 negative and 2 positives will give you a negative, and of course 3 positives will give you a positive. So these 2 guys over here are when this whole thing here is positive. So x is less than 0.